For lecture number 2, we're going to go into more basic sound processing, not so much the speech area, but just the basics of sound. As I said here, there is something very interesting called the psychophysical bridge. We know that the physical world of speech is composed of 3 major components: the frequency, the intensity, and the time. And those physical characteristics do map into the psychological, the perceptual aspects of speech, pitch, and loudness. Time doesn't really change. The other thing I really need to say is, and I didn't say this with the Wundt information, Wundt was really the first person to study sensation and perception because he asked people to basically perceive what they were having sensations on. So he was really the first person to study in an experimental way sensation and perception. But anyway, going back to our story here, the psychophysical bridge, page 262, really talks about this idea that in the physical world we can measure frequency, intensity, and time, and these do correspond in some ways to pitch and loudness, but it's not a perfect one-to-one match. There's a lack of invariance, as I said. It's not that you can just look at frequency and figure out the pitch of things, the intensity and loudness. Time is just one thing. So many times we look at this relationship between the physical world of sound and the perceptual world of sound, and there's no one-to-one match. There's really a lack of invariance. Variance means things change. Lack of invariance means it's not a one-to-one map. You just can't look at all the physical parts, and it doesn't map perfectly into the psychological components. Next, there's some very interesting things on page 262. It shows the amplitudes in decibels for environmental sounds. Barely audible, 1. Leaves rustling, 10. Quiet residential community, jet engine taking off. It's very interesting to note that wind turbines, I was doing a little digging on this, 43 decibels, which is basically less than a quiet residential neighborhood. It's kind of like leaves well, it's a little more than leaves rustling. So that's very interesting to note. And then on 266, they talk about, a audibility curve with listening to sounds. And the idea there is they look at the decibels of the sounds and what you can hear with frequency. And the idea is that basically the human curve, if something is very, very low, the threshold for hearing is very low. And hopefully you can just map that out and read that section and add some notes on the audibility curve there. So that's the nature of that one. Transduction in the ear. Page 268 to 272 kind of covers that. It's believed that the transduction part of the ear, when energy comes into your ear, the sound wave, the outer ear, the middle ear, it's the inner ear that really does the key things, and it's the inner hair cells. Figure 11.17 shows these hair cells. The main theory that we have on this, on 273, is called the place theory, that the way that you're going to perceive sound is basically by where on the basilar membrane the wave basically crests. So the hair cells will crest at a certain point, and if you notice on figure 11.18, that starts the whole action potential process of neurotransmitters being communicated up to the brain with action potentials, so the hair cells are the ones doing that. There's a lot more detail there, but I don't know. I think we're pretty good with where we are with that. Page 278 we go to next. And on page 278, as you get older, basically, you start losing some of these abilities. So add some information on 278 about a conductive hearing loss and sensory neural hearing loss as well. And some of the details in that section. So hopefully that helps you out. And that's about all I want to say about lecture 2. Thank you so much. Bye-bye.